Alright, so in this video I'm going to be reviewing the Year 12 mock exam, and I'm going to start off on this video looking at particle physics. The next video will be energy levels, and then the third and fourth videos will be looking at the circuitry questions on this paper. So let's get started looking at some particle physics. Okay, so we need to start off by completing these equations. So these questions, or this question in particular, is essentially testing whether you know the conservation laws that govern particle physics. And if you do, these questions are really easy, and if you don't, these questions are pretty much impossible. So you just have to go away and learn those. There's no excuse for getting these questions wrong. So let's see what we've got here on the left-hand side of this equation. So we've got a proton, so we've got a baryon here, so we've got a baryon number of 1 from that one, and we've got an electron, which is a lepton, so baryon number of 0, electron lepton number of 1, charge of -1, and we've got a charge of +1 here. So the overall charge on this side of the equation is 1 minus 1, so neutral, so this must be neutral here. There's 1 baryon here, so there must be 1 baryon here, and there's 1 electron lepton here, so there must be 1 electron lepton on the other side. So to have a baryon, we're going to have a neutron, and to have an electron type lepton, we're going to have an electron type neutrino. The overall charge here is negative, neutral even, so that works. You've got 1 baryon, so that works, and 1 electron type lepton, so that works also. Moving down to the next one, we've got a neutron interacting with a muon neutrino. Now we've got a proton here, so we've had some sort of weak decay because quarks have changed flavour from a neutron to a proton, so it's some sort of weak decay. But if we look on the left hand side, we've got 1 baryon, we've got 1 baryon here, so that matches up. We've got neutral, and we've currently got a plus, so we need something that's negatively charged, and we need a muon type. So therefore it must be a muon, and a muon is negative charged, so that works. And this next one down, we've got some very high energy collision between protons, which is allowing us to pair produce some other particles. So we've got 2 baryons here, 2 baryons here, so this must not be a baryon. And we've got +2 charge here, +2 charge here, so these two must be overall neutrally charged. And so we've also got a strong interaction here, so strangeness overall must be conserved too. So your K minus is made of an anti-up and a strange. So this one must have a anti-strange quark to cancel out the strangeness, and it also must make it a positively charged, so it must be an up anti-strange, and that particle is a K plus particle. So we've got strangeness conserved because we've got a strong interaction here. We've got baryon number conserved, and we've also now got charge conserved because these cancel each other out. Okay, so moving on to the next question. Represent beta minus decay using quarks rather than nucleons. So beta minus decay is when a neutron turns into a proton plus an electron, and it's the electron that makes it beta minus decay, and you have an anti-electron neutrino. So let's represent that in quark form. So a neutron is up, down, down. So that's what it's going to start with. That decays to form a proton, so up, up, down. So getting that right got you one of the marks for this question. And then it produces an electron which isn't made of quarks, so we can't represent that as a quark diagram. And we also have an anti-electron neutrino like this, and that got you second mark. In this first question, by the way, these were each worth 1 mark. Okay, so which fundamental force, so this is essentially, when it says that, it's essentially telling you it's either going to be strong, weak, gravity, or electromagnetic. Those are the 4 fundamental forces. Which fundamental force is responsible for electron capture? So if we sketch what electron capture looks like, you should have learned what the Feynman diagrams for this look like by now. This is electron capture, like that. And then we're showing our time. So what you can see in electron capture is a proton turning into a neutron. So that is a change of quarks, and any change in quarks is caused by the weak interaction. So that is the fundamental force responsible for electron capture, and the easy way to know this is to know your Feynman diagrams for the basic types of processes. There is no excuse for not knowing that kind of thing, it's just factual knowledge. Asking you what type of particle is an electron, it's a lepton. Again, basic factual knowledge, something everyone should know by now, no excuse for not knowing that. So we're looking for the other fundamental forces that electrons may experience. So an electron is charged, which means it can interact through the electromagnetic interaction. It's not a hadron, so it can't interact through strong, but it does have mass, so therefore it can interact through the gravitational interaction as well. So like both of these would have been acceptable. You can't write weak because it says state the other fundamental forces, so writing weak would just be repeating your answer again, which isn't answering the question. So that's the end of the particle physics section. So particle physics is something you should be getting 9 out of 9 for. This is all just factual knowledge and applying basic conservation laws, and there's no excuse for not being able to do this. So if you're not getting 9 out of 9 on this, you need to take a good hard look at yourself and do better, because this is where easy marks are and you've got to get 9 out of 9 here.